want to give you a tour of Rhino. Rhino is a pretty powerful software that allows you to build a number of different kinds of geometries. First of all, it's really like CAD. So I can type line and I can draw a line. I can type polyline, or in my case, PL. I've set up some shortcuts. And I can make a polyline, so I can make some shapes. And I can also do an arc. So I like to do a starting point arc. So if I just type S, and as you can see, I'm using the command line. So if I just start typing like sphere, so anytime you want to do something or make something, you're using the command line. Well, this is great. The other way, well, we can move something. We can type move, and then I can have a starting point and an ending point, and I can move that. This is just like CAD. There's also a widget, a gumball, they call it in Rhino. This gumball lets you move things around. It lets you scale in different axes. If you hold shift, it will scale every different dimension uniformly. You can also rotate. And if I do Control Tab, I currently have 4 different views. If I go to the perspective view, there we go. Zooming in and out, you use the middle mouse button or the scroll wheel to zoom in and out. And then to rotate, you use the right mouse button. And to pan across, use Shift and the right mouse button. So if I zoom in, you can see that I can rotate in any direction here. Now, there are a number of different kinds of geometries. The first kind is curves, and curves can have different forms. They can be linear, they can be curvy, they can be spline-like, if you're familiar with that in CAD, or Bezier curves, or sort of like Bezier curves. If you type interpolate, interp curve, you can click different points and it's going to try to keep the curve going through those points. So you can draw a shape that way. I'm just going to go back into plan, Control Tab to go into plan. You can also do curve, where you can draw the actual control points that are controlling the curve. This is much trickier because you don't know, until you get comfortable with the way to draw a curve, that can be a little tricky. But if we looked at each of these, they both have control points. This one was just created using those interpolated points that, we're essentially drawing points along the curve that we want the curve to pass through. That's curves. Now, there's another type of geometry which is really important for Rhino, which is surfaces. And if I were to take 2 curves, I can use my gumball here and move these above one another. I can take 2 surfaces and type loft, and it looks like it's trying to align them. So it's giving me a starting point. And I can, there's a number of settings here that I can change, but I'm just going to hit enter. And then I can also change the settings here as well. Is this a straight section? Is this a normal curve, a loose curve? Not curve, surface. I'm going to do loose just because I want it to be, pretty loose here. I can middle click and I can change my kind of view. So I can go to a shaded viewport. And I have a surface. Now a surface is interesting because a surface is really made up of, I always like to think that it's made up of curves. So there are curves going in one direction, in this case, these curvy curves that I drew. And then as you can see, there are lines running this way. Those are kind of curves as well. But in this case, they're straight curves or linear curves. Now, if I one way to demonstrate this is I can extract an ISO curve off of the surface. And if I select that surface, you can see as I move around, I can grab any curve off of that surface. So not only do we have the curves at different junctures, but we also have this mathematically figured out curve, or that solved curve that sort of falls somewhere in between all of those places. Now we can also toggle the direction here if we're extracting. We can click on toggle, and now I can select a curve somewhere between these two other curves. So if I click on that, and I can even do multiples here, and then hit enter, everything that you select is in yellow, as you can see, and these are selected automatically after I create them. I'll move these over with the gumball here, and now I have some curves that are taken from this surface. Pretty interesting. Now, we can manipulate these geometries in different ways. If it's a curve, you can grab a point and you can move that point around. This red and yellow square is the XY. You can also, if I type PL for polyline, you can also, and hit enter to be done with that command, select this and type trim and trim another curve. Right? So you can actually trim and manipulate curves that way. I can select both of these and type join, and they will join together into one single joined curve. You can actually have curves that have straight parts and curvy parts and arc-like parts. This is an arc that, it's going to have an actual radius. You can also do these kinds of things to surfaces. And this is how we get something like this, where we can create curves that define some sort of a plan, and then we can draw a surface simply by typing plane. This is only, really one way of doing this. And I can move this a little bit. I'm going to go back to my wireframe view. If you middle click and then go off of here and then middle click, it's saved. Middle click, go over here, and then right click. It's a little tricky, but you can do a wireframe. You can also do wireframe by just going up here. These are the different types of views of your geometry: wireframe, shaded, rendered, and then there are a number of other fun view settings you can do. But if I select this surface and say split, and select these curves and hit return, this will split this surface into three parts. The outer part, which I'm going to delete, this little part which got trimmed by this, and then the rest of this which got trimmed by the outer curve. Anytime you select geometry that overlaps, it's going to give you a little menu of which thing you can select. And as you roll over that, it will highlight the thing that you can select. So we want to select the surface here. If I just move this up a little bit, you can see the surface, the curve, the other surface. So that's really mostly how I got this plan created. I brought in an image. You can actually, link an image into Rhino and then trace over it with the curves, and then I split that surface with the curves. Control Tab here to change views. Another neat thing about the surfaces in Rhino is that you can untrim. If type untrim and I select an edge of a surface, and when I want to be done untrimming, I hit return. But as you can see here, I untrimmed the outer edge because there's no other thing determining where I would stop. It untrimmed that whole outer edge. If you have a hole within a form, so this guy here, let's make a copy. You can make a copy by holding Alt and then dragging with the widget. So this one has a hole in it, and I can type untrim and click here, and it will untrim the hole. And then, as I said before, hit return to get out of the untrim function. The untrim function sort of is like a mode. Trim is the same way, and I always find myself forgetting to exit untrim and trim even after years of using this program. So that's curves and surfaces. There are also meshes, and meshes are strangely actually always present even if you don't have a quote-unquote mesh object, because what you're actually seeing when you look at a surface is actually a mesh, because a surface is really this mathematically perfect thing, and the only way for you to see it is for the computer to draw an approximation of that surface, and that preview that you see is actually a mesh. Little fun fact. So if I select a surface though and type mesh, this is actually a command. I'm going to mesh that surface. I can give it all kinds of parameters as to how to mesh it. 0 generally means that you're ignoring that particular setting. I'm going to do maximum distance, and this is a very common approach that I take. You use maximum distance, and then visually your mesh is going to be very similar to whatever your surface was. I usually keep refined mesh, and I do not click these other settings. Then we can say OK, and it looks like it made a mesh. Let me click here and move this mesh over. As you can see, there are more lines here, and in some cases there are kind of other lines kind of in between. A mesh is never quite as pretty as a surface. If I select the mesh and type F10, this is the way that we get a preview of all the points in a mesh. You can do the same thing with the surface, F10. Oh, excuse me, F10. And you can manipulate a surface that way as well, similar to the way we would manipulate a curve. And then a mesh has points as well. Now, a mesh is a little tricky because once you've made a mesh and you go to move one point, it's really hard to sort of manipulate a mesh. And we often are using Grasshopper tools in LandKit to do these sort of things, and this is why we've built tools to manipulate meshes, in particular for landscape design. Now, the later tutorials will make it more apparent why you would use a mesh and how we manage that. But we're getting a sense of all of the anatomy of these different parts. We have curves, surfaces, meshes. There are some other things to understand, though, about Rhino. First of all, we have these panels here, and these panels can come and go by right-clicking and selecting which panels that you have on. But some of the main ones I'd like to show you are here. Some of them are not ones that I use very much, like materials or libraries or even rendering. Just personally, I don't use that. Or even help. So properties, layers, and names. Properties is going to give you, if you have nothing selected, it will show you things about your view. What is the lens length? What is the location of your camera? What is the location of the target of your camera? Things like that. And your camera being the point of view that you're currently in. So when I move around, it actually is changing this. There's a few other options here, but that's generally it. If I then select an object, watch what happens. All kinds of different options appear, and now it's giving me the information about that object. I can change the material, and very often we're using the layer material as the material, and that seems a little abstract, but every object is on a layer. That's why they have different colors. And we like to use the layer material so that if you put an object on a layer, it automatically assumes that material. There are also texture mapping options, which we won't get into for a little while. But if you go to layers, since we were just talking about layers, we can have layers with names, colors, materials. These are actually the materials here. And I have the order of these panels set up. You can actually move these around, but I like to have my current layer, my layer color, my material, and then my visibility and whether the layer is locked. Very similar to CAD, almost identical in a lot of ways. So I'm currently on the no plot layer, which is why everything that I'm drawing is appearing pink. If I wanted to move a geometry from the no plot layer to a different layer, so I will move this to a layer that's currently visible. I'll right click maps and say change object layer. And this is now red. And if I were to do a preview, middle click and go to the render preview view, it'll show me my materials for those layers. So this is actually a pink, a rosy pink rather than a hot pink. And what else about layers? You can also have sub layers underneath layers. So if I turn off one layer, so all of these layers are on the areas layers. So we have all these different material types, and I can turn any given one off. So I can turn lawn off, or let's see, path forest. So yeah, so there's path forest. Let me pick one. Plaza base. Plaza base, we'll turn that off, and there you go, it turns it off. But if I turn off areas, it turns them all off. So it's nice because you can organize things and toggle certain whole groups of things on and off, which is, we find very helpful. And it's also easier to, if you minimize these, you can more easily find what you're looking for underneath these different categories. That's layers. You can also set named views. So we don't actually have any set named views, but if I pick a view here and I say save, I can call this axon, and then I can rotate around, save, and call this axon 2. And now I have two views, and this may look different for you the first time you use this. I prefer, if you right click anywhere around here, to, under the view mode, to do list rather than thumbnails. And if you go to thumbnails, you can see the view, but what will happen is if you have a very heavy file, especially with a lot of trees or plants, these thumbnails will actually slow down the performance of your file because it's constantly trying to figure out what these thumbnails look like. So if I right click and go to list, I can go back to just having my views. And it's very easy to see what these views are. You just double click and you get back to that view, double click, get back to that view. Okay, so I've done a lot here in Rhino with the command line, and we haven't really talked too much about all these buttons. Each tab has a different set of tools on it. The first tab is standard. These are like a lot of the common things you would need to utilize during the course of working with Rhino. The rest are harder to kind of figure out which tab to click on at any given time. But a good rule of thumb is if you're editing surfaces, go to the surface tab, and there's a number of different tools you can use to manipulate surfaces. And there's always a menu that appears down here as well, which sometimes duplicates some of these things, but very often does not. Understanding how Rhino works and all of the different functions is a little more straightforward if you just start going through the buttons. You click and you sort of understand what are the different things each of these functions wants. It will prompt you for each step as you go along. And sometimes you may have to escape and then set up the geometries in order to test that out. But that's a good way to explore that. since we're here, I'm going to point out another thing, which is solid tools. These surfaces are all single surfaces, strangely enough. But this surface in particular, because it wraps around and has no openings, it is actually considered a solid. If I have two of these, I can do a special operation called a Boolean, which if I type Boolean difference, I can select the first set of polysurfaces, and then I can select the second set and hit return, and it will remove the second set that I selected from the first set. So if I move this over here, you can see that it cut. And you can do different kinds of Boolean operations. You can do a Boolean union, which joins everything together. You can do a Boolean split, which splits it into all the parts of all the different overlapping pieces, I believe. There's intersect, which will do only the space between the two. You can do difference, which we just saw. There's a lot of different options there. You can do filleting, but the point here is that these are all the Boolean operations. The point is that surfaces and solids are both kind of made of the same thing, but a solid is a solid if it's closed. This can also be a solid. If I type cap, it will close this surface. And now this is a solid, but it's also considered a poly surface because it has more than one surface. And you can only cap if you have a flat face where a cap can go. A cap is always going to be a flat surface. And so keeping things solid if you're doing some really strange modeling is always an interesting challenge. And Boolean can actually help with that. If you build with it solid shapes that are simpler and you do Booleans, you can always make sure that you're ending up with a solid Boolean at the end, for the most part. There are a number of other solid tools, but maybe one to look at would be fillet edges. So I can select an edge and give it a number. We're going to do 1 and hit return again. And I zoom in, and this has done a fillet on this edge of 1 foot. These are actually massive forms because this is a site here. I'm in units of feet, and you can actually change the units. Let's look at that. Type units. These are our Rhino settings. This is actually, you can get to this by typing options, but you can go straight to the units options by typing units. We are often working in feet with our tools and in our firm. That is going to change if you work in inches or if you're not in the United States or the UK, and you may be doing metric. So that's something to definitely pay attention to if you're receiving drawings that have sizes that are of a different system. The other tab that is important is mesh, the mesh tools tab. This lets you clean meshes up, and if you're doing any work with meshes, you'll be in here a lot. There are different ways of manually cleaning things up in a very grueling way where you can flip mesh edges, you can remove faces that aren't valid, you can delete individual mesh faces, you can rebuild the normals. There's a mesh repair wizard if your mesh has some inexplicable things happening. That's a good thing to use. And you can do mesh booleans, mesh splitting, mesh trimming. And that's something to note. The trim tool that we used before works on surfaces and it works on curves, but it will not work on meshes. In order to trim a mesh, you have to type mesh trim. Okay, so that's giving you the general idea. There are rendering tools for Rhino. We're not going to get into those, and to be honest, I don't use them very much. A lot of folks will use a plugin called V-Ray for Rhino, but Rhino has kind of a new rendering engine, which I think is interesting, and you can actually look at this in the preview. So under our settings here in the corner, if I select ray traced, it will go to a kind of, you can see the granularity here. This is actually bouncing light around. And if I grab one of these pink spheres and move it here, you can see that there's a bit of pink light that's bounced onto this surface. If I type sun, you can also add lights. There's lights options, but if I turn this on and then I hide this, this is creating, it's casting a shadow and it's bouncing the light around. You can even see when you move around like these little specks of colors bouncing off from other things. But the longer you wait on any given view, it will smooth all of these pixels out because it's sampling, and you can see that it's using cycles. This is a rendering engine that it uses. This is also used in Blender. But this takes some time, and you can see the number of steps it's going through. And after a while, you get an intuitive sense that, okay, a 500 step render takes a minute, or, with relatively simple conditions. But if I had really complex stuff, that would take 10 minutes or something. So the neat thing here is that you can make renders essentially right in Rhino, and you can type view capture to file. And this actually re-renders, by the way, but if you select this option, you don't actually have to wait for it to do however many passes. You can determine how many passes it will use. You can tell it what the size is. You can tell it also whether you want a transparent background or not. So if you're doing a PNG, you can actually have a transparent background. I often have these settings turned off: the grid, world axis, and C-planes. Those are some of the things that, let me just cancel here. If you see this or this, these are kind of items that you don't want to show up in a rendering. But you will notice that the curves were showing up, so that's something that you can either utilize or you'll have to turn those off before you do a view capture with ray trace. I think it gives you way more flexibility than the Rhino render options. And that, for now, I'm going to say that's Rhino, and I encourage you to explore. You can download the 90-day trial from the Rhino website. You just search for Rhino 6 or Rhino 7. I'm using Rhino 6 currently, and Rhino 7 in certain instances. But yeah, next we'll look at Grasshopper and how Grasshopper can change your workflow for how you build things. Thanks.